who's a veteran on the processing, and he knows dye stuffs and everything in such a, in great depths. And he's doing a lot of work to make sure that, the pollutants, as they are generally called, all the dye stuffs, there are nearly 800 different types of chemicals that are used in processing currently in the textile industry. How is it that we don't really consider them a pollutant? And, it kind of reduces the impact of, the negative impact that come through for wet processing in the textile industry. So over to you, Karun. I know you really have very, very technical terms, but since this webinar is for everyone, just, try to speak in a language which all of us will understand, right? Okay, thank you. Over to you. Yeah.
Thanks, Annika. And definitely, I will try to keep it more simple and from the perspective of the entire industry, not from the perspective of what my company is right now doing. So I'll at the end, I'll go with the example of the most sustainable way of doing the things. But 99% of my presentation is going to be about the industry. So I'm going to talk about what is the wet processing industry and what impact is going to it's making on the environment, and followed why we call the effluent coming from textiles hazardous effluent, and then going to speak about the sustainability of the sector, and then followed by what happened in the last decade about the sustainable solutions, and then going to touch a little bit on certification part, because that's becoming very, very important part of any textile wet processing unit, because there is a lot of certification and people are confused about why brands are requiring so much certification, and followed by the aspirational chemistries or aspirational processes where the future lie for this industry. And then, as I said, I will share an example, and at the end, I summarize the gist of the presentation. So I'll start with my presentation. First slide.
Beautiful. Karun, I'll only be the timekeeper, just to say that we will sum this up in about 10 to 12 minutes.
Sure, I'll do it. Generally, there is a complaint from the moderator. See, I finished my presentation too quickly. So I think it's better for you.
No worries. Thank you so much. Yeah. All right.
Okay. The next slide, please. So as I said, I'm going to speak about, in general, what is the wet processing, to make people understand what we generally do in this particular process. So as I said, the textile wet processing is referred to the process where we apply chemicals and dye stuff to the fabric to give it more desired look. Okay. And while doing so, we treat the fabric or the garments to different processes. Okay, so in general, we divide the wet processing into two segments. One we call the textile wet processing, where we do yarn, fiber, and fabrics. And then there is another segment which is called garment wet processing, where we do all kind of effect on garments. Okay, so if we talk about textile wet processing, what we do in textile wet processing is pre-treatment, where we make fabric, yarn, or fiber ready for dyeing. And to do so, we do scouring and bleaching, where we treat the substrate to make it better for dyeing, receptive for brighter, darker colors. So that's a process that we call pre-treatment, followed by dyeing, where we do different kind of dyes. In textile, we use different kind of dyes, but most commonly used dyes in textile is reactive dye stuffs, followed by wax, direct, sulfur, pigments. So these are the common form of colorants that we use in textiles. After coloring, we go for the finishing, where we apply softeners, silicones, and enzymes to make fabric softer and more visibly appealing. And thereafter, we do specialty finishes on textile if it's required by the brands, like water repellents, UV protectors, flame retardants, antimicrobials, and many more. So there are many kind of specialty finishes that goes onto textile. And if I talk about the garment wet processing, the first thing which is most common in the garment wet processing is garment washing, where we wash the garment with detergent. We do enzymes to clean up the protruding fibers, and then we do softening. So that's the most common thing. For the garment dyeing, generally we do, like, as I said, in textile, the most common dye stuff is reactives. But in case of garments, the most common is pigments, followed by sulfur, directs, and reactives. And then denim washing, which also contribute a lot to the environmental impact, which include the desizing, the bio-washing, the bleaching, the tinting, the PP spray, the potassium permanganate spray, softeners, and resin. So a lot of chemicals goes in treating the denim as well. And then again, the finishing, where we do finishing like wrinkle resistance and water repellents. So this is a general overview about the wet processing. Next slide, please. So as I said, we use a lot of chemicals while doing the wet processing, and definitely it is going to make a huge impact on the environment and social sustainability. So these are the few points which highlight what kind of impact this process is making overall. So more than 8,000, it's not 800, it's 8,000 dyes and chemicals that have been used in textile, garment, and wet processing. So we can see the huge amount of dyes and chemicals that has been used to make a fabric desirable or make a garment desirable. Okay, loss of colorants to the environment can reach to 10 to 15%. That means what dyeing we are doing, 10 to 50% goes into the waste. Only 60 to 70% goes onto the fabric. Rest goes into the waste. 80 to 150 liters of water is being used to produce just a 1 kg of a fabric. So tremendous amount of water we are using in the textile wet processing. 2.5 billion tons of wastewater is discharged annually in the textile industry, which is roughly 70 to 20% of the total industrial wastewater pollution. So see the kind of impact we are making to the environment. 20% of the water pollution is done by fabric dyes and chemical treatments. In all the wet processing hubs, estimated that 90% of local groundwater is polluted with the textile dyes and chemicals, and 75 to 100 toxic chemicals identified in the water supply chain. Toxic chemicals identified in the supply chain. Also, wet processing contributes 36% of carbon dioxide emissions, CO2e, which is all the greenhouse gas emissions, a terminology to define the greenhouse emissions in the textile supply chain. Textile effluent is a toxic cocktail of inorganic and organic chemicals. So it's not a very simple effluent. In general, if you see in different industries, they have a quite a simple, be treated very easily. But in case of textile, as I said, is 8,000 plus chemicals that has been used, and different chemistries, organic, inorganic, dyes. So it is very difficult to treat the effluent. And wet processing operations occurs mainly in the developing countries. So if you see, the major wet processing operation develop or goes into developing nations with the limited ability to treat the effluent. So all the, like, if you see the major hubs like Ludhiana, Panipat, okay, now Tirupur is an exception now because of the Supreme Court order. But if you see all other hubs in textile, they have an issue of limited ability to treat the effluent. So the entire thing makes a huge impact on the environment. Next slide. So why we call this effluent is hazardous, okay? So every industry is producing certain kind of effluent, but why specifically we call the wet processing effluent more hazardous than the any other industry? The reason is clear, which I mentioned in my last slide also, that we use a tremendous amount of chemicals, which are organic and inorganic chemicals. These substances going to add high amount of BOD, COD. That means a biological oxygen demand and chemical oxygen demand for the water. So that goes up very high while we are using such high amount of chemicals. TDS, that means total dissolved solids. TSS, total suspended solids, and extreme level of pH. So it's not like we are working in the neutral range of pH, which is 5 to 8. We are working on extremely difficult pH like highly acidic and highly alkaline. And it's affecting these effluent and these chemicals affecting the health of human and aquatic life. And we found these chemicals to be very persistent and in the nature, and it's causing the CMR effect, which is carcinogenic, mutagenic, and reproductive thing to the human beings. And it is very, very harmful for the aquatic life. And it results into all kind of a problem like cancers, acute illness, skin problems, reproductive issues, genetic issues in the newborns. So this effluent is very, very harmful. Next slide. So in this slide, I have mentioned one point which is very important. So there is a table on this slide, and people can read through that because I don't want to go into too technical terms related to textiles. But is the BOD to COD ratio, where I mentioned it is for the textile effluent it is in the range of 1:4. Generally, the safe BOD through COD ratio is 1:2. Okay. That means we are using the chemicals which are not biodegradable. So we are using most of the dyes and chemicals which are non-biodegradable, and that requires very high cost in the water treatment plants, as well as it's become persistent in the environment. Okay, so that's a very critical issue into the textiles. Next slide.
Karun, can I ask you a question here? Because
right.
It is also a question I think most of our industry people would be interested. Thank you for telling us that how much impact our pollutants, our dyes, the dyes that we're currently using is having an impact on the environment. Just wanted to understand for the benefit of the manufacturers that who are the organizations or who are the manufacturers who are actually making the sustainable alternatives of these chemicals and these dyes. If you could shed some light on it or maybe mention a few names. So, my second fold to the question is that are these aspirational sustainable alternatives available easily in the market, and do we really need a consultant like you to kind of help the manufacturers to put this whole process into a system, or is it like that you can just walk off to the organization, a mill or a producer, pick up these dyes, pick up these chemicals and start using it in your own infrastructure? Does there have to be any change in the infrastructure or the machinery or maybe a water effluent plant? What is it that is needed to adopt this?
Okay, so to answer your first question about the availability and the suppliers of this kind of aspirational or sustainable solutions, yes, there are many available. But it's not like a single company is making all kind of a solution. So the vendors needs to go and search. Okay, just to take an example, there is a dye company who's making a particular set of dye stuffs which are sustainable. Right now, they probably don't have a range to cover up all the shade gamut, but they are working towards that. So people can go and see different dye stuff company what kind of dye stuff, sustainable dye stuff they are making into it, what kind of claims they are doing it, because it is very important in the industry. Because the previous speaker also talked about the greenwashing. So lot of greenwashing happening across, whether it's in fibers or dyes and chemicals or fabrics, or the different kind of claims done from the chemical industry as well. So people need to be aware about it, what they are getting into it. They should ask a lot of questions about it. They should understand the terminology which I said, like BOD, COD. These are not very complex terminologies. These are very, very simple terminology. because they are dealing these terminology day in, day out because of effluent treatment plants. They understand this terminology, and they need to ask questions to the suppliers why their product is more sustainable compared to, like, if you compare red dye to a red dye. So if somebody is claiming my red dye is more sustainable than somebody else red dye, so they need to ask question about it, why it is sustainable, whether it is making an environmental impact, or whether it is good for water treatment, or it is non-hazardous, or what it is. So they need to ask a lot of questions, and then there is a suppliers available. And in last 10 years, every company, whether I can take a name like Huntsman, Archroma, Dystar, Proclean, Shudjan, Jindal. So there are many companies, they are offering some kind of sustainable products into the market, but it's not a whole range. So like I can give an example of my company where I'm working. We are only working in the segment of sustainable chemistries, but our range is limited. So we can offer a solution for pretreatment and dyeing right now, but we don't have a solution for the dye stuff. So people need to understand that not a single company can make the requirements, all the sustainable requirements. They need to search it, ask for the questions, and check the parameters, check the claims made by the different companies.
Karun, I'm sorry, I'm going to be the timekeeper. We are at about 7:45, and I know you have so many interesting topics to cover. I think we will have to create a knowledge sharing series for you, one full webinar. Sure. Just for the extent of information you're sharing with us. It's unbelievable. We keep the Q&As for the last. That's why I'm being the timekeeper. Karun, please carry on.
Yeah, I quickly, slide, please. Yeah. So what happened in the past decade, as I mentioned, there is definitely there is shift in the industry, and there is a lot of efforts happening from both the sides, like from the buyer side, from the vendor side, and from the manufacturer sides. So I have mentioned like low impact dye stuffs like low salt, high fixation, low wash off, indigo, soluble sulfurs, safer chemistries, natural dye stuffs, adoption of right first time, which is very important in the industry. You need to hit your target on the first go. You don't need to reprocess, because when you reprocess, you again put the chemicals and you use a lot of waters again. So right first time is like, if your right first time is around 90 to 95%, you are done by reducing load up to 40%. So right first time is a very important concept. Then RSL to MRSL, which is very important nowadays, because in past we only check the restrictive substance list. That means we are checking on the garment. We are not checking the effluent. But now the focus is shifted from RSL to MRSL, which means manufacturing restrictive substance list, which means you are going to check all your inputs and all your outputs. So there is a terminology in computer, it's called GIGO. That means if you're not putting a garbage inside, you're not going to get the garbage outside, okay? But if you put garbage in, you will definitely get a garbage out. Then the chemical management, that is CIL. That means whoever is using, they should know what they are using, chemical management. Previously, 7-8 years before, people are using the chemicals. They don't know about what is the hazard, what is the risk. People are taking the chemicals from bare hand. They are taking a dye stuff. They are inhaling that. So now there is a system in place. It's called chemical management, chemical inventory list. It's called CIL, where everybody knows what they are using, because that's the important thing. Then partial bio-based products, that's happened in last decade, and low material to liquor machines, and innovations like laser, ozone, foam, mist application, waterless polyester dyeing, that happens in last decade. Next slide, please. Okay, and as I said, I will talk about global certification. So quickly, these are the certifications which identify the hazardous nature of the chemical. So they ask what are the chemical of concern. They try to eliminate that through supply chain, and they try to find out the alternatives or lacking. They inform brands that there is no alternative for the particular chemical and it's hazardous, so they need to drop out. The classic example is water and oil repellent, where all the brands are using the PFC chemistry, which are very hazardous, carcinogenic. Now they shifted to different chemistries, sustainable chemistries, but without oil repellency. So now brands are satisfied with the water repellency because there is no alternative to that. So shifting from hazardous to non-hazardous if there is no alternative to the particular performance. Next slide. So these are the few programs offered, like ZTSC, Zero Discharge of Hazardous Chemicals, ChemIQ, Blue Sign, Cradle to Cradle, GOTS, REACH, and Ocotex and Green Screen. And now there is a Green Deal that is coming up, being forced by EU nations. That's going to affect the textile supply chain tremendously. And that's itself is a very huge topic and can be covered in next webinars or something like that. Next slide. So what is the aspirational? Aspirational, I mean Industry 4.0. What it means? Non-hazard chemical synthesis, that you are not using any chemical synthesis. You are using all the bio-based products. Design the safer chemicals and products. That means completely non-hazardous. Here I'm not talking about less hazardous, less toxic, safer. I am saying completely non-hazardous and non-toxic. Take it in your hand, use without the use of personal protective equipment, PPE kits. So I am talking about those chemicals, which is completely non-hazardous. Design chemicals and products to degrade completely after use. That means you use the chemicals, gives a maximum efficiency, and whatever left in the water, that can be easily biodegradable. So there is two terminology. One is readily biodegradable and completely biodegradable, that you need to see whether your chemical is readily or completely biodegradable. Then bio and microbial based dyes and chemicals, that is the future for the industry. Industry will shift dye stuff. Even for the cotton, we are seeing a lot of microbe-based cottons coming into the market. Same way for the textile industry, for chemical industry, lot of products will come for chemical and dye stuffs. Minimize or elimination of waste. Right now we are generating so much sludge for the ATPs that we need to minimize that. So that is the important aspect, that we need to have a closed loop system where we are using a chemical. We are using the maximum efficiency of those chemicals, biodegradability, and whatever is left can be recycled back. So we can recycle the chemical, recycle the water, and it becomes a closed loop system. Okay. And then we also need to see the energy economics. Okay. As I said, 36% of carbon dioxide emission the wet processing is generating. Okay. And it's the highest in the textile supply chain. So that also needs to be seen. Next slide. Just 2 minutes, max.
Okay.
Max.
Yeah.
Okay, so this is a picture which show the existing and aspirational chemistries. If you see existing, start with the crude oil and goes to the manufacturing. People can read the details. And the aspirational ones start with the microbes or a bio-based products. No temperature, nothing, all thing in the ambient condition, and which produce non-toxic, non-hazardous biochemicals. Next slide. So to summarize, what we need to do: green chemistries, safer chemistries, aspirational chemistries, Industry 4.0, reduce BOD-COD ratios, bring it to 1:2, reduce water energy time, zero liquid discharge, reduce water and chemicals, and waterless technologies. Thank you.
Brilliant. Karun, for the last slide, I think we need a full 1 hour session with you. Everybody wants to get into the aspirational chemistries and reduce the impact. So thank you very much. Unbelievable data and presentation, and we will certainly connect with you again one more time.